Alright, welcome back. Now that we understand that there's some basic conceptual idea here, without putting any numbers to it yet or anything, that a warmer world might be a rainier world, or at least have a more active hydrologic cycle, let's see what the IPCC report, which assessed all of that research and all those data sets and so on, what does it say about observed changes in the amount of precipitation? Now what we're going to be doing is we're going to be working with some of the figures that you saw when you did those readings in the IPCC report. You did do them, right? That is important. I know they're dry, I know they're hard to make it through, but, well, they're dense, but they're the jargon of our discipline, okay? Now what we're going to do here is we're going to be looking at this figure that comes from the IPCC report that shows records of precipitation anomalies over a period of about 110 years. And on each of those graphs there's multiple lines, each of which represents a different data archive. Remember, we have different sources of information, like the official National Weather Service stations versus co-op stations versus other ways of measuring precipitation and so on. So for each of these different graphs here, there's actually multiple data sets. But if you actually look at them closely, you can see how each one, on any given graph, they kind of track each other pretty well. Or they might have used the same data, but they use different techniques to analyze it or whatever. And you'll notice that there's 1, 2, 3, 4, 5 graphs on this diagram here. It's because those are for different regions of the world. The top graph there is for the region from 60 north to the North Pole. The second graph is from 30 north to 60 north. The middle graph there is for the tropics. The second graph, second from the bottom, is for the southern hemisphere mid-latitudes. And the bottom graph there is global. Okay, so that's all the differences between these different diagrams that you see here. And let's focus on the global one for a little bit here. So this is the global analysis of precipitation. You see there's some variability here because this is, now this is actually, from the caption of the figure, this is actually just over land. Land's only 30% of the area, but it's certainly where we have the best data. We don't have a lot of great observations of precipitation over water. And I just glibly say here, all 4 of those data sets, or however many are in there, show an upward trend. Now you might have to squint a little bit to see an upward trend there. Well, I wouldn't have, if there is an upward trend here, it's certainly not compelling. But, well, compelling isn't necessarily the most important thing. What about statistically significant? Is there an actual quantifiable, we can develop a hypothesis and test it in a rigorous way, consistent with the scientific method? Absolutely. So we can actually use those global data sets, again there's 1, 2, 3, 4 of them here, and determine what the trend is from, as it happens in this IPCC report, they used 1901 to 2009, 2008, as you see circled there. And for each of them, they determined a trend globally in terms of the total amount of precipitation, in terms of how much it was increasing. Now it looks, the units here are a little screwy. They're saying how much did the precipitation increase from the beginning of the period to the end of the period, okay? The units of precipitation were millimeters per year, and then they're just taking the difference between the, like how much did the precipitation increase over that period. Okay, they're not saying it increased 2 millimeters every year globally. That would be a very large amount. Okay, so here we have their estimates for the 4 different archives of how much of a trend in precipitation there was. And what I want you to see here is that they have error bars associated with them. There we know with a 90% confidence that the precipitation is increased by 2.77 millimeters per year, plus or minus 1.46. In other words, it could be as little as whatever the minus and as much as the plus, with 90% probability. So that first one there is statistically significant. What does that mean? Statistically significant means we can prove, with like a scientific method, hypothesis testing, that there is a positive trend in the amount of precipitation that's happening in that data set. Okay? And we can tell that because, like, look at the third one there. That data set, GPCC version 6 from Becker et al., their global average trend was 1.46 millimeters per year, plus or minus 1.65 millimeters per year. Well, their 90% confidence interval spans 0 and even includes some negative trends, right? There's a 90% probability that somewhere in that range, well, some of those ranges don't even have the same size, right? Same sign, rather. So we don't even know necessarily the sign of the trend in the Becker et al. Data set. So, but 3 of the 4 archives are certainly showing some positive trend that is statistically significant for that time period here. Yeah, I already told you that. Make sure you're happy with those units, the trend here. What they did here is a bit tricky about the units there. Now, when you look at that, you'd be forgiven for thinking that's not very convincing. I mean, when I look at this graph, I'm always a little bit doubtful of results that don't seem to be there. I mean, apparently 3 of these 4 curves here actually do have a statistically significant trend from the beginning of the period to the end of the period. But statistically significant isn't always the same thing as clear or important or whatever. I think this is not so compelling. And in fact, if you go back here, the range of these trends that these 4 different archives are using, that's actually a pretty big range of trends. That's kind of tricky. I mean, there's almost a factor of 3 between the different estimates of the trends there. And if you actually, okay, that was all for 1901 to 2008, but if you just choose the last 60 years of the record, where presumably our observations are better, none of the 4 archives show any trend for the last 60 years. I'm not feeling that comfortable with this, okay? Maybe global precipitation records aren't showing us what we thought we were going to see, namely some kind of trend associated with global warming. Okay. Well, we have all these different latitude bands to work with. Okay, the bottom diagram, which was the one we were looking at, was for global precipitation, but maybe there's more precipitation in some parts of the world. Maybe most of the increase has been in some parts of the world. Let's decide that. All right, well, that's what they tried to do in this diagram here. Now, this is a mess. This was in your reading, but I would certainly understand if you did not figure all the captions and so on as to what this means. So what we're going to do here is we're going to start picking this thing out. I'm going to take from each of those 4 archives, let's just look at the results for 60 degrees north to the North Pole. So that's the diagram that we see. I just sort of made a little inset there. That's from where we were seeing before. These are the 4 different sets of results of the estimates of the trend from 60 degrees north to the North Pole. Now, there aren't enough data to do that for the full period of 1901 to 2008, so let's just look at the 1951 to 2008. And what I've done is I put a check mark by the ones that show that there is a statistically significant trend. Okay? I put an X by the ones, the data sets that show that there is not a statistically significant trend. That might be not quite the right word. At a later lecture, we're going to make sure we all understand about hypothesis testing and so on. But for now, let's be clear about this here. The one with the X there doesn't say there isn't a trend. They're saying we can't prove there's a trend with this data. Well, what you can see here is 3 of the 4 data archives are showing that at high northern latitudes there is a trend. In fact, some of these trends are pretty big. I mean, look at how much bigger these numbers are than what we saw for the global values. 5.88 millimeter per year trend and so on. I think we can say with great confidence here, with moderate confidence anyway, that at high northern latitudes there's probably has been some increase in precipitation over the period. Okay, well, now remember, that was also where we saw the warmest temperatures and the greatest temperature, I'm sorry, not the warmest temperatures, it's the North Pole, but the greatest temperature increases, the greatest temperature anomalies, and so on. Okay, maybe we're starting to see, maybe the precipitation increases have mostly been at high latitudes. Let's try this over here. Now we're looking at the mid-latitudes at the northern hemisphere, so 30 degrees north to 60 degrees north, as you see in that little inset diagram there. And again, from each of the 4 data sets, I'm highlighting the row that's associated with that latitude band's results. And, well, it's a little bit more of a mixed bag. You can see for the longer period, all of the data records actually indicate that there is a statistically significant trend. See how all those ones in the 1901 to 2008 column, I marked with a check. They all are statistically significant. They all have a 90% confidence interval that does not span 0. We know that those trends are positive. Okay, based on the observations, we can now say in a scientifically rigorous way that there is a trend. But you can see that's a little less convincing if we go over here to look at the second column, which is the more recent period where presumably the data are better. So if there is a trend, it's certainly, more between the beginning of the period and the end of the period, not like something we see year on year. That's a little less convincing. I'm not sure I believe that there's more precipitation overall in the mid-latitudes. And in fact, we can go back and span, let me back up here for a second here. I'm having more trouble with my tablet today. All right, if we span, for example, 30 degrees north to 30 degrees south, you know, basically the tropics and the subtropics here, and look at that little inset diagram, I don't know that I see any kind of trend in that data. And in fact, literally none of the data archives in either the long period in the first column or the shorter period in the second column show a statistically significant trend. Nobody shows a trend. Okay, so what we can say here is apparently in the tropics there has not been an increase in the amount of precipitation. Now that doesn't mean that there aren't places in the tropics that have seen an increase in precipitation, but the tropics as a whole haven't. That might be a clue as to what we're going to be finding later. Okay, and for what it's worth, in the southern hemisphere mid-latitudes, 60 degrees south to 30 degrees south, you can see once again it's kind of a mixed bag. Some data sets are showing some increase, some data sets are not. The more recent period doesn't show any of them show a statistically significant trend. I think we can kind of say that we're not seeing it here. So, what does the IPCC report say about precipitation? It's saying that if there is a trend, it certainly gets stronger the farther north, towards the North Pole you go, the farther poleward you go. Okay, so we definitely don't have it. Well, the data sets certainly don't let us prove that there is a trend at the tropics, and the data sets certainly do seem to show that there is a trend in the polar regions. Okay, but that's such a temptation to like just label big chunks of the Earth, like from 30 degrees to 60 degrees north and call that the mid-latitudes and then average the precipitation all around the mid-latitudes. That certainly is a very tempting thing to do, but it isn't necessarily the best, most scientific thing to do because, well, frankly, that region, 30 degrees north to 60 degrees north, spans a lot of different environments. Like, you know, there's some deserts and there's some farmlands and there's mountains and so on. Maybe we should look a little bit more regionally. Like, for example, look at maps of precipitation. So what this is again a diagram that was reproduced from your readings in the IPCC AR5. And what this diagram is showing here is in 6 different data archives, what kind of trend do they see? Oh, I'm sorry, it's 3 different archives. There's 2 different periods. From the first column is from 1901 to 2010, and the second column is just the more recent period of 1951 to 2010. And this is just looking and seeing what are the trends in the precipitation. Okay, and so places where there is blue on there, there are positive trends. The amount of precipitation is increasing, and places where there are brown colors on there, that's where the precipitation was decreasing over that time period. And as we zoom in on some of these diagrams, you're going to see that there are locations that are kind of marked with a little star or a plus sign. Those are the ones where actually it was statistically significant. How, you know, you could in a rigorous scientific way prove using that data that there was a trend. Well, when you start looking at this, you start seeing that there's quite a lot of regional variability. I mean, there are places that are definitely getting more moist, and there are places that are definitely getting more dry. Now, in this analysis here, any place where there was either no trend or not enough data to show a trend, you know, then there's no coloring in on those archives. But let's just kind of zoom in here. Let me look at North America for a little bit here. The data sets are clearly showing that most of North America is getting more moist over this time period. Okay? And in fact, you can see with the little stars or plus signs or whatever they are on there, quite a number of these grid points are actually statistically significant. It would definitely seem like this idea that as global warming happens, we should be having a more active hydrologic cycle seems to apply quite well in North America, where we have really good observations. Just to see here, you can see though that in other parts of the world, like in tropical West Africa, we have statistically significant trends where the precipitation is decreasing. Oh man, that's bad news. I mean, those people are very dependent on water resources. There's a lot of agriculture. There's a lot of, there's relatively poor like water retention behind hydrologic dams and things like that. There's no doubt about it. Much of tropical West Africa has gotten quite a bit drier. If I move forward as soon as my tablet catches up with me there, you can see that if you look through all of the data sets there, you'll see that all of them showed that like Northern Europe is getting wetter and Southern Europe is getting drier. This is another interesting regional factor. Memorizing where all of these trends are isn't necessarily the point. So much as showing, oh, there's a lot of regional variability as to how global warming is affected. Well, global change, anyway, seems to be affecting the distribution of precipitation around the world. What are we going to be able to make about that? Before we go on and start deciding what kind of interpretation do we have about all this, let's go ahead and answer a couple quick questions. Question 6. Theory predicts that global precipitation should increase as global temperature increases. Do the observations show that this is happening? A. Yes, there is a clear statistically significant trend in global precipitation in all major archives. B. No. None of the major data archives show any statistically significant trend in global precipitation. Or C. Not very convincingly, some data archives show trends over time, over some decades in some parts of the world though. Which of those three is the best answer? This is kind of more of a food for thought type question. Let's decide what we think the observations are telling us about global precipitation.